Hey everyone, Morgan coming back at you here. We're on page 3 of the lecture outline for Thermochemistry and Honors Chem, and we are going to look at heat and work as it is quantified. Quantified meaning we're putting some numbers on this. Our equation for calculating heat, Q equals mc delta T. Lowercase q is the letter that we use for heat. M is mass, C is heat capacity, and delta T is change in temperature. All right. Our equation for work in a physics class would be force times distance. In a chemistry class, it is minus P delta V. But as I've said previously, we're really not going to do a whole lot with work inside the Honors Chem class. Okay, we do a lot with heat. So let's look at a couple problems. And in the first one, I'm going to do something odd. I'm actually going to work this problem in calories, which is a non-standard unit, unless you're going into food science, nutrition science, and then the calorie is still used in this country. So I'll do one just so you've seen it that way, but then we can pretty much ignore it from this point forward. Q equals mc delta T. We have 15 grams of water, its heat capacity is given, and there's a temperature change from 10 to 15.0 degrees, and we would like to know how much heat is absorbed when this happens. So our mass is 15.0 grams times. The heat capacity is 1.00 calories per gram degree. We can write it as degrees Celsius or degree Kelvin because temperature changes are the same in both of those. And then delta T is 15.0 minus 10.0 degrees Celsius. Now that looks a lot like 5.0 degrees Celsius. Degrees Celsius cancels degrees Celsius. Grams cancels grams. Okay, and I have 5 times 15. And if I'm doing this right in my head, that's going to equal 75 calories. Now, that's a 2 sig fig answer based upon this right here. When I take this difference and I'm looking at places after the decimal because it's subtraction, that gives me 2 sig figs. All right, pretty straightforward. The equation can be rearranged in this second question. Q equals mc delta T, and I am looking for the temperature change. Delta T equals Q over mc. So I've got 25 grams of water, heat capacity given in joules, absorbing 50 joules of heat. So 50.0 joules divided by 25.0 grams, and a heat capacity of 4.18, I miswrote that, sorry, 4.184 joules per gram degree. Now the joules are going to cancel, the grams are going to cancel, and I'm left in degrees Celsius, which is good, it's a temperature change. And when I do this math, okay, it comes out to be 0.48 degrees Celsius. Yep, that makes sense. It's absorbing heat, so the temperature should be going up. It's not going up an awful lot, but that makes sense also, because it turns out water has a pretty high heat capacity. Okay, and that is it for page 3 of this outline. See you next time.